Hello guys, welcome back. So today our topic is a system design of a key value store that we'll cover today. And in the interest of the time, I have already prepared the content and I have Vishal with me who is preparing for the system design. So let's start. Yeah. So today we will be covering system design for a key value store. I believe you must have come across many times a key value store kind of a database that we'll have to, or a Redis, cache where we use a key and then we update and create a value into that. So Redis is one of the example of that, right? And there's a key value store like in a Cassandra is a one of the key value store, you know, and DynamoDB is a one of the database that is a one of key value store, right? So the expectation of the today's design is that we will cover the high level architecture, that how we will design such a system. Will not go into the database depth, but when we build a distributed key value store, it is more about how we are managing the different operations and how we are there are too many other services, how we are implementing those services, right? So I'm not going into that how we will create a database files and all. So that is not the system design for key value store, and that is generally not expected in the interview as well also, right? So let's start. So what we have the functional requirement. We have a functional requirement like enabling key value insertion. You have a key, and then you should be able to create a value, and you should be able to update into your key value store, right? And there should be an ability to update that. Given a key, we should be able to update the existing values for it, right? And allowing the retrieval of the value using the specific key, right? So given a key, we should be able to retrieve that that key and their corresponding value. And offering for option to delete a key, we should have an ability to delete a given a key and their corresponding value. And this is one of the extended requirement, I would say, uh, where we would be supporting that secondary key as well also for the searching and filtering. Let's say I have a sort of a key and the value is like of in a JSON, right? And the JSON has a lot of an attributes. Let's say a car, there is a car ID, car registration number, and the corresponding car objects we are updating into the key value store, right? So given a car attribute, let's say I want to filter out all the cars that color is red, right? So this is not the ideal situation where we are having a key, we are fetching the value. But here we wanted to find all of the cars that having the color red, right? So that is something a secondary key support, so we can, if the time allows, we can I can talk about that. But this is one of the extended requirement to how to support that secondary key for searching and filtering and the existing all of the keys, right? Let's move to the non-functional requirement. So these are very important requirement that we should generally cover in our system design interview as well also. What are the non-functional requirements? Non-functional requirements generally are which are not being concerned by uh, the client who is being using our system. It is concerning for the for the person who has developed the system, who are managing the systems, right? So it is behind the scene requirement, like in a company who is building such a system, like in ensuring high system availability. When we say the system should be available for 99.99% of a user, right? It should be available most of the time, and and providing the scalability to 100 the 1000 write QPS is a query per second. So assuming we are building such a systems for an Amazon web store or e-commerce systems as well also, where there's a lot of traffic is being coming, and or this is being used by the e-commerce where they, for their internal purpose, they are updating a key value into that. So we can expect the 1000 write uh, per second, right? And maintaining the high availabilities, ensuring the 100% data is not lost. The system should be highly reliable, right? And the system, we can assume that in the case of, since we are building a distributed systems, and keeping that we want to bring that availability is a major priority, then we'll have to, you know, compromise the consistency. We cannot keep the strong consistency as well, because we are favoring a high availability and we are lowering that strong consistency to the eventual consistency. So this system is like a high available system and partition tolerant as a AP kind of a system in the cap theorem. So in the cap theorem, we have a C, consistency, availability, and partition tolerant. We are focusing more on availability and partition tolerant, right? So this system is a AP system, right? Like in a Cassandra is a database, which is an AP system, right? So, and keeping the request latencies less than 200 millisecond. Obviously, our latencies of an API should be as less as possible. It should be, the operation should be very much in real time happen, right? Let's discuss, the capacity estimation, right? So capacity estimation gives an idea what kind of the system we are building, right? So let's cover that. So assume we are writing the 100,000 query per second, right? It means, and let's say assume the maximum key size that we are supporting in our system is a 256 character. So key can be of maximum 256 character. We cannot support unlimited length of a key, right? We should have some limitations. We should limit the length of the key, and assuming the maximum value size is, the maximum value, the value could be anything. It could be a JSON, it could be a text file that you have updated, but or it could be a string, but in simple terms it would be a sort of a strings, and right. So it could o- so it could be a anything. So value is a, like an unstructured opaque for you, and it could be some structured JSON as well also, you can put it into that. But ultimately it would be treated as a byte array of bytes, as a blob, right? Assuming the total so
So
assuming the max. Yeah, go ahead.
are we treating the maximum value size of 1 MB as it like it's a fixed kind of block in the DB, or is it like flexible? Some values can be lesser than 1 MB, some values will be
The
greater than 1 MB.
maximum it size of the value is supported of 1 MB. The lesser is fine, but it should not be more than that of it. Okay. So the
No,
hard
like
limit
different
of the
values can be of
value.
different size, right?
Yeah, different value of
Different
can be of
values can
different
be of
size.
different.
But this is by the maximum limit. Assuming the maximum value size it's some 1 MB. Let's say it's a
Okay,
10
got
kb,
it.
20 kb, 500 kb. It's fine, but it shouldn't be more than that of 1 MB for any of the value in my
Okay.
key value store, right? Assuming the total
Okay.
size of, so I mean, since we have has made an assumption, uh, uh, what could be the length and what could be the maximum value size that we are supporting, we can calculate the total size of given key value pair is approximately 1 MB. 1 MB plus 256 byte, approximately 1 MB. So we are doing just rough calculation here, and so now estimating the total daily data, since we have say assumed 100 query per second, so 1000 into 10 to the power 6. So 1000 query, each query of 1 MB size, 1 MB is nothing but 10 to the power 6, and the total number of seconds in a day, right? Total number of seconds in a day. Uh, Total number of seconds in a day is nothing but 86500. If you calculate 24 into yeah, 60 into 60, this will come around. So I've assumed is a 10 to the power 5, 1 lakh, right? So 10 to the power 5. So so if we done that calculation, we come to know that for a one days of the data we have, for total size is that we are accumulating 100 TB, right? So 10 to the power 3, 10 to the power 6 is 10 to the power 9. 10 to the power 9 is into 10 to the power 5 is a 10 to the power 14. And 10 to the power 12 is a 1 TB, right? So it's a 100 TB. Okay. So projecting the total year's data is a 36.5 petabyte. And estimating the data for the 10 year, we are building, we are This is a very high number, so because the key would have the some expiration as well also, right? We have not, so we can also keep that in the consideration. The key would have the some latencies, or if this is a persistent store at all, so then we can assume that estimating it will remain throughout the 10 years. So total data for the 10 year that we will be acquiring is a 365 petabyte, right? And that's a maximum, and maintaining the read to write ratio, assuming for a given a key value pair there is a 10 is to 1 ratio, okay, read to write ratio. The anticipating the total read request per second is 10 to the power 4, is a 10,000 requests per second. So you can assume that the scale of the system that we are designing, okay. Now, to support such a requirement, so 100 query per second and total read query per second of 10,000 requests per second, what is the expected bandwidth that we should, our systems should support, So expected bandwidth, we can calculate the write QPS into size. So write QPS is 1,000 query per second, and the size is approximately 1 MB, which is equals to the 10 to the power 9. So we need a 1 GB per second of bandwidth for the write. And given that we have assumed that 10 to the power 1 ratio read to write, so 1 GB into 10, the 10 to the power 10 GB per second is the expected read bandwidth. So we need a maximum of 10 GB, at least 10 GB bandwidth per second of it, right? So we should have expect that kind of internet support to that system, right? Now let's move to the overall design. We'll cover the API design and the deep diving into the system component in my next video. But in the first part, we will cover high level design of it. Okay. So this is a high level design, and we have, okay. So we have a client application, and we have a API gateway. We have a Redis cluster. We have a web application. There's an authentication and authorization, and we have a partition lookup service, and we have a database nodes, okay, Dynamo DB, you can say. I'm not taking the Dynamo DB as a managed service, okay, mind it. Otherwise, what would be the point of building such a system, distributed key value store? Because Dynamo DB in itself is a distributed key value store, right? But I am just using that Dynamo DB as a client software, so running the nodes and all these operations, like service discovery and all, we are implementing ourselves. So right, so it's not a all of these other operation we are implementing in house in ourselves, right? So don't be confused that since we are, DynamoDB itself is a key value store, so why we are uh, what actually are building on it, right? If I was using the DynamoDB directly, I would not have built these all of these components, like these all components, right? This would have gone, and I would have been using DynamoDB directly as a managed service. So that would have been hosted on that, Amazon, right, or AWS or wherever, and I would have been given a URL. I would be directly hitting that. But this is the system that we are building. Hence, we have a separate component being detailed explained, and these are the just the database node or LSM kind of a storage engine, and we can also use a Cassandra as well, or a Cassandra software here to run that node or database here, right? Or we can use a DynamoDB. So now let's move to the client application. So how, let's just think and deep dive how we use that, distributed key value store. There is a too many ways. One way is I am in my internal application. I have for my internal requirement only, right? I have a client where the client is nothing but the client application where internally, let's say there is a client application, a service, or let's assume the Twitter service is running. That is a client application, right? And they have a requirement to keeping saving the key value storage. Let assume given a Twitter ID, they want to store a Twitter as a key value storage, right? So the client would be treated as internal Twitter service. and we are agnostic of that. The client could be Twitter service, or there could be any other service also. I'm just taking an example so that it can be easy to understand how do we use, what are the ways we can use the distributed key value storage. So internally, we can, the client application, the Twitter service would be running some client library of our distributed key value storage. That is a one way. As in, like, the Redis, we to connect to the Redis, we have a Redis library that we install at our client application side, and using the Redis library provide an interface to us to connect to the Redis cluster, right? We do not directly initiate the HTTP call and all, or API request. So that's a one of the way that client itself handle a lot of other operation. Client library of the Redis has that operations, and it makes the API call to the Redis cluster. That's a one way. Other way, since we have created an APIs for our systems, right? So we have an API gateway, so and we have an APIs as well also, as in I have mentioned here. So client would be agnostic of that. Client just have to make an API call. It's like so, and it is an independent. They do not have to uh, you know they do not have to use that my distributed key value storage client library at their side, because they just have to make an API call. An API call, so it is an independent of. That's another way we can use that. We can use our distributed key value store, right? So these are the two ways which I can think. Either we use a client library of my distributed key value storage at the client application. In that case, we can, park, we can remove a lot of other components here, the web applications. Probably we might not need it because it just, but I have made the system as it will be accessed as an API. Okay, hence I will need some other components as well also. So client will make an
So
API
which
call.
one would be better?
It depends upon the
Like which?
requirements. Let's, because
Okay.
here I am just providing this distributed key value storage as a managed component. So I am agnostic of the whoever the client application is. So if I have to be agnostic of the client application, I will have to provide my I will have to provide an APIs to access my, because API can be accessed by any of the client. They do not need to understand my the internal operations and all, right? So that's a one way, and this will provide me to onboard lot of other clients. So that is the one of the advantage of building as a managed service and giving them as access using the APIs. The other way is, let's say I am building a Twitter service, and in between, in the Twitter service only, I wanted to use this distributed key value store, right? And so I want to use this for my internal purpose. No other application would be using. So in that case, I may skip some of the component, like, API gateway, because these are just creating an additional hops. Ultimately, I'll have to reach one of the application node and just update into the database, right? But that will, if they are looking for a high, I mean, very good latency, we can park off some of the component, but that would be very limited to that application, right? That would be very limited. Uh, they will be using my client library and the client distributed key value storage client library. They would be consuming in their application, and using that interface, using that library, they will make a call. They will not make a directly API call, right? So it's like a thick client that they'll have to use at their side. And the thick clients, like in a WhatsApp client we use, that has a lot of context in it, to it. It knows what is the current state of my chatting and all. So basically, thick client has and thick client has a lot of context about it, of my servers. So but that the advantage of that is just provide me, it is very tightly coupled to that system only, right? It is rightly, but I want to be agnostic of that. Any of the client I can onboard of it. Hence I have given an operation using an API ways. Okay. So Okay, so client application would make an API call. It will land into the API gateway. API gateway, the Redis cluster, we can use a Redis cluster for the highly, let's say there are the some key value store that is being accessed very frequently. So we can store some set of a key, that highly accessed key, into the Redis cluster. Okay, so hence we are at the Redis cluster. There is an authentication and authorization service that I have created. This is just for the authentication and authorization. I don't want to allow any XYZ client who has not onboarded with me but is still being able to persist, and create a key value store in my system. So authentication and authorization should be there, right? uh, During an onboarding, they can register to my service, and using that, I would assign them some client ID or secret key or API key that they can use for every successive operation call and all, right? And okay, so Redis cluster is for that, and for accessing the frequently accessed keys. Web application are the stateless node. Okay, so any request will, if request is doesn't find into the Redis cluster, let's say for a given a key, I want to find a value. If it didn't find into the Redis cluster, it will forward it to the one of that web application node, and that web application nodes will, you know make a call. Web application, okay, now web application make a call to the database node, right? But using a given a key, what are the data node that they will be using it, right? But there is a very important role of the partition lookup service here, right? How the web application node know which of the node it has to connect given a key, right? Given a key, how it will figure it out, uh, how it will figure it out ki, okay, this set of range, uh, this set of, let's say, what we will do, there will be a request for a key and value. Let's say I want to insert some key and value into the my distributed key value storage, and now I'll have to figure it out, given a key, which node I'll have to persist to, right? So what we generally do, we use a MD5 hash. We create a hash out of the given a key, MD5 hash, or there could be other a lot of other algorithm that we can use. Using that hash, we got a very long number of 128 bit, right? So string for a given a key, we'll find a hash out of it, and that MD5 hash, and using a consistent hashing, we can, we can convert into the some integer number, right? And that integer number, now that that's a basically range of tokens. So every node may have there some sort of a range being assigned. Let's say 1 to 25 will be handled by the Dynamo node 1, 26 to 50 would be handled by the node 2, and 51 to 75 would be handled by the node 3, and 76 to 100 range of token would be handled by the node 4, right? But how does the web application upfront get to know, okay, this range belongs to this node, right? That information application does not have, right? So those are the information we will discuss how we can leverage that partition lookup service, Prakka service discovery. These are the very standard problems, and the standard solutions of such a problem. We call it as a service discovery. Every service that has a more than a one node, one services, then there has to be some service discovery mechanism for them, because every caller does not have an list of IP address and port of every service, so that it can connect to each of them, right? So there should be the some simplified way of knowing, okay, this it has to connect to whom, because services and node can go up and down. It may, it probably the service has down, particular node has gone down, and when the new node come up, it may have a different IP address and port, right? So but so hence we has to have some mechanism like in a service discovery to figure it out, okay, this range belong to this partition, and that partition has a IP address this and this, right? So those information are being maintained into the partition lookup service, right? So in the yeah, I think we have covered that high level system design, and let's just go here. Uh, yeah, okay. Uh, In the next design, what we will do, we will cover API design, and we will in the next part of this session, we will cover we'll deep dive into the each of the components. Why I have chosen, NoSQL DB versus a SQL DB, and what are the partition strategies that I'm going to use, like in a leaderless and leader and follower. These are the important concepts that interviewer will ask you and will judge you. Do you understand that why have you have chosen this? Do you have the reasoning for that? And that will partition lookup surveys, what are that, information will be maintained into the partition lookup surveys and all, right? So we'll cover into the next part of this series. Okay. And thank you for hearing me out, and let's hearing me out here. Okay, guys. Bye bye.